Thank you for watching.
Astronomers discover the brightest quasar in the known universe. What is hiding inside the remnant of supernova 1987? The success of the first ever commercial moon landing and the mystery surrounding the size of the Kuiper Belt. My name is Rob,
my channel
and
for
this
more
is your Space
information.
Fix. Last week, reports heralded the discovery of the brightest object in the cosmos. It is, they say, fueled by an enormous black hole, one that weighs billions of times the mass of the Sun. Every day, it consumes mass equivalent to that of our solar system, and around it swells an enormous cloud of debris and gas. It is this cloud that glows so brightly the force of the black hole drives immense frictions within. The cloud, heating the gas and dust to tens of thousands of degrees. The resulting glow outshines our star 500 trillion times over and, as a result, is visible across half the known universe. These are unimaginable numbers, so much so that even astronomers struggled to believe them at first. When the object was first discovered in the 1980s, it was initially misclassified as a nearby star. Nothing else, they thought, could possibly be shining with such intensity. In truth, however, quasars and stars do look rather similar. Although quasars are distant objects, they shine brightly and appear as dots of light to telescopes, just as nearest stars do. Only in the 1950s, when radio telescopes started to map the properties of stars in more detail, could a distinction be made? Some of those stars, it turned out, were emitting a weird pattern of light. Their colors, especially when examined in radio frequencies, seemed to indicate an odd, even unexplainable collection of elements. And strangely, they rapidly shifted in brightness, especially when viewed with X-ray cameras. Astronomers of the time were baffled by the observations. Clearly, though, they were not stars, and so they labeled them quasi-stellar objects or quasars, and set about investigating them in more detail. The data soon showed they were small objects, stretching no more than a light year or two in diameter. They also turned out to be extremely far away, with most appearing at distances of billions of light years. The question of how something so small could possibly be so bright led to some interesting speculation. Some proposed clouds of exploding antimatter or suggested we were seeing the gateways of wormholes. By the 1990s, the truth became clear. Quasars were supermassive black holes, and their brightness came from clouds of debris swirling around them. The quasar reported last week is the brightest yet found. It appears to be consuming matter about as fast as physically possible, and seems to have been doing so for rather a long time. Whether it can keep that rate up and how it is being fed will be questions for future surveys of this extraordinary objects. In February 1987, a new star appeared in the sky, shining brightly in a nearby galaxy known as the Large Magellanic Cloud. Waiting telescopes soon confirmed it was a long-sought event, a nearby supernova, the first to be seen by modern technology. None other had been visible to the naked eye since the days of Kepler some 4 centuries ago. The supernova and its aftermath proved a wonderful opportunity for astronomers to learn more about these violent events. Among the discoveries that followed was the detection of the first neutrinos from deep space. A dozen were spotted at an observatory in Japan, a tiny fraction of the untold trillions that must have washed over the Earth. In the years since, however, a mystery has lingered around the dying star. When giant stars explode, they are not completely destroyed. The core of the star must collapse, forming either a neutron star or a black hole. Yet for decades, astronomers were unable to find any such marker at the site of the supernova, leaving a question mark over the event. Partly, that is because the object, whatever it is, lies behind a cloud of dust and debris. Although telescopes like Hubble have watched the cloud for years, they have never been able to peer through it, and so could not uncover the black hole or neutron star that should lie behind it. The arrival of the James Webb Telescope changed things. Soon after it was commissioned, astronomers trained its eye on the site of the supernova. Although the telescope could not see the star directly, it did see signs of gas being blasted by radiation from some energetic objects that, according to a paper published last week, strongly suggests a neutron star is lurking behind the debris cloud. Left unanswered, however, are questions about the exact nature of this neutron star. Many take the form of a pulsar, a fast-spinning star that sends a jet of energy sweeping across the cosmos. To find out, we'll need to take a closer look at the exact elements around the star. Over the past few months, the James Webb Telescope has been collecting data needed for this study. The results of that survey should come sometime in the next few years. A private company has finally landed on the moon. Last week, Intuitive Machines picked up a weak signal from their Odysseus spacecraft, proving that the lander was alive and well on the lunar surface. It is the most southerly landing ever achieved on the moon, and the first done by a company rather than a government. Though the landing was successful, it was also rather shaky. Engineers had apparently forgotten to flip a switch before liftoff, leaving its laser rangers turned off. That left the probe without crucial speed and position measurements as it descended towards the surface. Fortunately, and no doubt thanks to some quick thinking, operators were able to patch in a separate laser system to the navigation system. Although not designed for the task, it proved well enough to guide Odysseus to a landing. Despite touching down, Odysseus landed roughly a mile from its target.
Even worse, the probe seems to have tipped over, leaving its solar panels tilted away from the sun. That has left the spacecraft short on power and thus seems likely to bring its mission to an early end. Still, Odysseus did land, and that at least makes the mission a success. The mission targeted the southern lunar pole, a region of high interest among the world's space agencies. Future astronauts may find ice hidden there, a crucial resource on the otherwise barren moon. Yet recent studies suggest the pole is also unstable. Back in the 1970s, instruments on the moon picked up long moon quakes, shaking its terrain. A new analysis of these quakes show they originated around the South Pole, suggesting a series of active fault lines exist there. Strong moon quakes may, therefore, pose a threat to future visitors. 9 years ago, New Horizons flew past Pluto, giving us our first close-up views of the distant world. Ever since, the probe has been flying onwards, traversing the vast region known as the Kuiper Belt. Dozens of small and icy objects are known to lie there, circling the sun in slow and immensely distant orbits. At some point, scientists expect New Horizons to cross the outer edge of this belt. This boundary was thought to lie around 50 times further from the sun than the orbit of the Earth, a distance New Horizons reached back in 2021. Recently analyzed data from the probe, however, has shown no sign of this expected edge. The spacecraft instruments are still picking up high levels of dust, a sign that the Kuiper Belt extends further than thought. Exactly how much further is still unknown, but it could stretch on for another billion miles or so. New Horizons at least has plenty of time to study the question. The probe is expected to keep running for another decades. So what did you think about this week's subjects? Let me know in the comments section below. I hope you enjoyed episode 2 of Space Fix, a new series of videos that I will be making in collaboration with Alastair Williams, a brilliant writer who shares a passion for all things space related just like us. If you want to read some of Alastair's other articles, then click on the link to his page, The Quantum Cat, in the description of this video. There's plenty to get stuck into over there. Thank you for watching, and I'll see you next time.